idea. Why
Yes.
don't you change the setting in the Zoom so that whenever you enter a class or you host a class, the recording just starts by itself.
No, it's manual is better because sometimes it takes time to go to the main class. Okay, the students comes late.
So you
You
can
know.
edit it.
Yeah. So now look this one, the bullet one. You are saying you are giving
Yes,
in
sir.
metal wall. So does it working like football? That is deforming and returning back to its position. What is called elastic and what is called plastic deformation? In our notes we gave you, right? Hello.
Yes, sir.
If the object is deformed and it's returning to its original position completely, that is called elastic deformation, right? And if it is not returning to its original position, that is called plastic deformation. So for
Okay,
ABC,
sir.
we are getting plastic deformation, not elastic deformation. It's not coming to its original position again. If it is deformed, write it there. So it's only happening for football. It's deforming elastically. Karim,
Yes, sir. I was writing the point. Done, sir.
so all the MCQs are done, right?
Yes, sir.
That is structured part.
Yes, sir. At first, I wrote change in shape where it exerts the force.
Yeah, state two effects that this force has an on rubber, right? So
Yes, sir.
if
Robert
you are
cracks.
applying force, then what will happen to the rubber?
Change in shape where it exerts the force.
Yes, then another
I
point.
didn't wrote anything else.
This is one point. Change the shape. Then,
Sir, there is not another.
huh?
I guess, sir, I just wrote only one point.
Okay. You wrote only one point. So another point is heat is produced.
How, sir?
Heat is produced due to friction. Huh?
Okay, sir.
The next,
Sir, you need to see the graph.
one is graph.
The graph. Sir, yes, this one.
You please use ruler. Huh? For
Okay,
the
sir.
first part, it is a straight line. It is exactly straight line. Okay. So you use ruler for this part. Please do it now. If you are drawing this way roughly, then you will not get marks. The
But I
part
didn't
which
use
are,
a graph paper or
yeah,
those forward.
not necessary graph paper. You just use ruler from the origin. You draw one straight line for a while. Then you just give curve line freely, freehand. But this part you should give with ruler because it is straight line, hook slope.
Okay,
Not necessary graph. Graph is not necessary. Just ruler is enough. Okay, do it, huh?
okay, sir.
So what you wrote here, it returns to
It returns to its origin position.
will it return to our original position?
Sir, in bracket I also wrote form.
Look here,
FORM.
what is written? What's it written here in B, part B? And also in your graph you showed it, right?
Yes, sir.
So will it return to original position? If it's crossing elastic limit, will it return to its original position?
No, sir.
So what you should write? It will not return to original position.
It doesn't return to its original position or form.
So you did this part, right?
Yes, sir.
Let me check what you did. So you did not draw it?
Sir, I did. Yes, sir. Sir,
Where?
sir, you just missed the graph. Sir, it's
Where this mass
sir
is
উপরের
the
দিকে sir.
this one is
Sir,
previous.
আমি
Okay,
sir
okay,
এটা
I
আমি
got
draw
it.
করে
Okay, another one. Okay, I understand.
yes sir. Sir, এটা একটু blurry চলে আসছে। এটা আমি
Okay,
খেয়াল করি।
okay. So 7 Newton, more than 7 Newton is carving, right?
Yes, sir.
You should draw with ruler, huh? Till 7 Newton. Next time you do it with ruler.
Yes, sir.
Then actually this one is available in your paper.
Sir, it will be 19.
Yeah. So determine the weight of the wooden block. Let us check. The length of the spring increases from 4.9 to 13.4. So what is the extension?
It's 41.6. Yes, sir.
The length of the
Oh, the
spring.
extension is 8.5 centimeter.
So write it here. Extension is 8.5
Sir,
centimeter.
I already have that on the formula. I just check my copy.
So it is 8.5, right? Extension.
Yes, sir. E for extension,
So
you
what
told
you are
me.
doing? Why you are doing this formula?
Sir, for the weight, forces
What they asked you to find the
weight.
weight from here this way, or you will find it from here the graph. 8.5 is where? Check it here, huh? 8.5. This part is 8. 5, then 6, 7, 8. 8.5. It's coming here.
Let me just zoom in.
Yeah, then 3.1. The load is 3.1. So the load is 3.1. You do not need to do it with this. You don't have the spring constant. Where did you get the spring constant? Did they give you the spring constant?
Yes, sir.
Why did you get this spring constant? 4.9.
Sir, 4.9.
Why did you get it?
Sorry, it told that it increased from 4.5.
So is it spring constant? Spring constant is centimeter. Where you got this unit? Extension is centimeter. Length is centimeter. So you cut this, give a big circle here, and you write here only. The extension is 8.5. So from the graph uh, corresponding to the extension 8.5, the weight is 3.1 Newton. That is load. Is it clear?
Yes, sir.
Okay, then see. So the student increases the load. So what you wrote here? Okay. So what you wrote here, those check
Yes, sir.
these 2 points are coming or not. The first point should be the here 2 marks, right?
Yes, sir.
So the first point is the load is shared into
Sir,
halves.
it is actually a big paragraph. You should just read it.
Again,
So I wrote a brief paragraph. You should just read it because
yeah,
that's
yeah,
not
I
really
I
difficult.
I read it. I read it, and I will also try to get those 2 points. First, you write 2 points. So the first point is the 9 Newton we are getting. Just listen, then we will check. Huh? 9 Newton will be shared into halves. Okay, in these two. So each of the spring will get 4.5, right? Each of the spring will get how much? Hello?
Yes, sir.
Each of the spring will get 4.5 Newton load, right? Isn't it?
Sir, I can't understand you.
For both the springs, we have 9 Newton. So 9 Newton will be shared in both the
Sir, is
springs.
it 9 Newton or 7 Newton?
It's written here 9 Newton. Look.
Increases the load to 9 Newton. Oh, understand.
Yeah. So this 9 Newton is shared equally in both the springs, right? So each of the spring is
Yes,
getting
sir.
4.5 Newton. Is it clear?
Yes, sir.
That's why the answer should be no. The limit of proportionality is not reached. Okay, so you wrote here no because the first spring, so limit of proportionality was 7 Newton, and when the add up springs the same force, those divide up for each spring. Therefore, its limit of proportionality is 14 Newton. No, this way it's not actually this part uh, is unnecessary. You do not need to write this part because you are writing therefore its limit of proportionality. Its means what? Only one spring. Hello.
Yes, sir.
So only one spring they already told that its limit of proportionality is 7 Newton. Here if you write therefore for two springs the limit of proportionality should be 14 Newton, and it's actually not necessary to give their limit of proportionality. Already we know that. Already they gave it. You just tell that each of the spring shares 4.5 Newton, which is not crossing limit of proportionality 7 Newton. Is it clear?
Yes, sir.
So write this. You you wrote no, that is fine. You wrote till here, it is fine. But after this, you write what I said. Or I should write. Should I write?
So it is blurry.
Is shared shared equally in both the springs. So each springs gets 4.5 Newton load, which does not.
But sir, what I wrote is also correct, isn't it? Because
You
their limit of
your
proportionality is now 14 Newton,
it's like
and
this type of writings actually we define as too vague because you wrote here therefore its limit of proportionality is 14 Newton. So it can never be happen that it will be 14 Newton.
sir,
Only
both
one
of the
spring.
springs, sir
If you
uses
write
7 into 2.
and
Sorry,
that's
I
not
also mentioned two springs in the bracket.
two springs, yeah, and the force acting on it was 9 Newton. So this one, what you wrote, you keep it there, and you also write this. Huh? Try to make your wording shorter because in exam time you are not getting too much time.
Sir, for 4.5 Newton.
Yeah, each of the gets 4.5 Newton load, huh? Which does not cross limit of proportionality. So here we wrote no 9 Newton is shared equally in both the springs, so each spring gets 4.5 Newton. So if you write till here, that's also fine. The other part, which does not cross limit of proportionality, I wrote only for you. Is it clear?
Yes, sir.
Okay, done. You wrote it. Hello.
Yes, sir.
Then next, State two other properties of the object which may change when the force velocity change. So these things I told you before.
I think so.
State two other properties you wrote. I think I told you. I can remember that. I told
Shape
you.
of the object and
Shape of the object you did not write, huh? Another one is slowing down the object, huh? Or stopping the object. Another one is changing the size, volume change. So you write,
change in volume.
yeah, change in size. In bracket you write volume, like inflating balloon, squeezing the sponge. These are examples. So its weight is very easy to get. One, two. Weight, you wrote what? The unit of weight is,
Newton per kg.
no, no, weight is only Newton, huh? It is one kind of force. So its unit is only Newton, not Newton per kg. Newton per kg is gravitational field strength, G. Okay?
Yes, sir.
Then the spring is suspended vertically and load is attached. So, okay, another spring. Suggest one reason why the extension of the same speed differs from 2.75 2.7 centimeter. So why it is what you wrote? Okay, listen.
Yes, sir.
Yeah, here you see these two springs are one after another, right? So this one should be 2.7 centimeter. Uh, this one and this one both, right? Because we are giving the
Didn't
same
understand,
load.
sir.
If they are attaching one after another, then they should have the same extension, right? Not shared
Yes,
like
sir.
before.
Because it one
Yes.
after another is also equal to side by side, isn't it, sir?
No, no, no. One
How,
by,
sir?
yeah. If one after another, then this load is working on both of them equally. The load is not shared. So that's why the extension should be equal. But there is another thing here, like this is spring and this is spring. If you think that this spring has uh, more load than this spring,
Mm,
can you observe that this spring, the first spring, it is first spring and it is second spring, right? So
that's what I understood.
the second spring has only the load, right?
Yes, sir.
But the first spring you have the load and also the
along with the load of the spring.
weight of the spring. So this one will have little bit more extension because of this extra weight.
Means a slighter, larger extension than the second one,
Yes, yes,
which
yes.
might be in nanomillimeter
Maybe
or
something
something.
we don't know. We don't know how much it is because the
But
load.
we can say that there is more.
Yeah, there is some extra load or weight working there. That's why there will be more extension. That's it. Is it clear?
Yes, sir.
So write it. Write it here. Karim,
Yes, sir.
done?
Just a second, sir. Done, sir.
So this part is over. Then what we have next after this? Explain what is meant by limit of proportionality. What you wrote?
After which the object cannot come back to its original position
Okay, correct.
after
This
being
one is
extended
fine.
to a certain limit.
Yeah, correct. Then next, see the load in figure 3.1 is pulled down below its equilibrium position.
Yes, sir.
Okay, state the form of energy stored in the stress springs. The load
Elastic
is released.
potential energy.
Yes, the load is released and it moves upwards after the distance traveled in each movement. Okay, now it stops moving. Okay, now then what you give? No, this one you will write that the energy is transferring, right? Energy cannot be damaged, or it cannot be
It
uh,
can only be
it cannot be
transformed
going
or
anywhere.
turned into something else.
So
It can't be destroyed.
yeah, so what happens actually, this kinetic energy converts to
Sorry, isn't it elastic potential energy?
elastic potential energy is there, but you see it's moving upwards and downwards, right? It's released. The
Yes, sir.
load is released. When it is pulled down, stress springs, it is elastic potential energy. But when you released it, then it's getting kinetic energy. And it's moving upwards, downwards. When something is moving, it's kinetic energy, right?
Yes, sir.
So distance traveled in each movement decreases until the load stops moving. It's because the kinetic
It
energy
has reached
converts
its
to,
original form.
yeah, it converts to heat energy, yeah, due to friction with air with the springs each other. So you write it because the kinetic energy,
Has been transformed into heat energy.
yeah, is lost as heat energy or transformed as heat energy due to friction with air and spring. So done. Hello.
Yes, sir. Done.
So today we we are done with the worksheet of deformation also, right?
Yes, sir.
So now I will upload the notes, notes and worksheet on pressure.
Okay, sir.
Then we have 20 minutes left. This 20 minutes you just go through the notes, not even the
Okay, sir.
worksheet. Just you go through the notes, and next
Sir,
class we
won't it
will.
be enough time to explain the pressure?
No, I think you will understand it, huh? If
Okay, sir.
if you go through,
If
you
I
will
don't,
understand
then
it.
I shall ask you.
Yeah, you ask me, no problem. I think you will understand everything. These are very simple things. Yeah. Already you did
Yes, sir.
pressure, right? So
Yes,
if
sir.
you are done with the notes, you can try the worksheet also, right? You do not need to
Okay, sir.
send me. You just keep it with you, huh?
Yes,
And
sir.
you will do one favor for me. That is, you will send me.
Yes, sir. I remember.
You will send me the corrected worksheet and the test paper, huh? Test paper 3 and corrected worksheet of deformation. Okay?
Okay, sir.
Okay, thank you, huh?
Okay, sir. Have a nice day.
Okay.
So shall I take my leave?
Yes, sure.